Okay, so now we're in section 6.3, the kind of final version, if you will, of our linear equations and the formations that they can be lined up in. So up to this point, we've talked about two other forms other than the one we've talked about today, which is standard form. We've talked about slope-intercept form, which in my opinion is my favorite. I think it's the best one. Slope-intercept form, which doesn't really say slope-intercept. Let me see if I can adjust my computer here so it's a little easier to write on it. Okay, here we go. Slope-intercept form, which is y equals mx plus b. I'm going to underline the key parts of this, m and b being the slope and the y-intercept. We've also talked about point slope form, which looks like this: y minus y1 equals m x minus x1. Again, I'm going to underline the y1, m, and the x1 because that's the point and the slope. And now we're looking at standard form. I'll just leave it called standard. Standard form is actually going to be this. It's going to be ax plus by equals c. Now, really, the main thing, standard form is kind of the most useless in general, but it is one of the most commonly seen in problems. Typically, we like to write standard form into slope-intercept form. That's usually what we try to do the most. Still, standard form is helpful, especially with word problems, I think, more than anything else. But it's this. You essentially have the x term and the y term together on the same side of the equal sign, and then your constant term, or whatever is a basic number, over there on the left. So examples of each. Slope-intercept form, an example of that would be y equals 3x plus 7. That would be fine. That's slope of 3 and a y-intercept of 7. Point slope form would be like y minus 2 equals 3 and then x minus 8. Or again, you have the slope of 3 and the point of 8, 2. Right? Standard form, an example of that would be something like 2x plus 3y equals 12. Where you have the x term, the y term on the same side of the equal sign, and then the constant, the thing that's not the x term or the y term, just a regular number on the right side. So that's what standard form is. Now, if we scroll down, here are 3 equations in each form. We have standard form, you've got slope-intercept form, and you've got point-slope form. Now, the funny thing about this is that all 3 of these, they're actually the exact same equation, just written in different forms. You can go from standard form to slope-intercept form. You can go from point-slope form to slope-intercept form. You can go from slope-intercept form to standard form. You can go from point-slope form to standard form. There's a lot of different ways you could mix these two up. I won't get into that too much because if it weren't for this fraction here, it would get a little messier. But yes, these are all the same exact equation, actually. Just take my word for it. Okay, you can write any equation in any of the 3 forms. Now, each one has their own benefit. Each one's good for their own reason. So what we're going to look at in A and B here is we're going to circle true for us. You can read the slope from the equation. So standard form, you cannot actually see the slope in the equation. The slope's not 2 or 3 or negative 12. The slope is not given to us in the beginning. So standard form, I can read the slope from the equation. That's false. That's not true. Slope-intercept form, I can see the slope. The slope here is negative 2/3. That's the slope. I can see that in slope-intercept form. You can read the slope from the equation in point-slope form. Point-slope form, yes, because it has the slope in that form. So the only form that you cannot see the slope in is standard form. The slope is negative 2/3, and you wouldn't know that just by looking at standard form. But you can see it in slope-intercept form and point-slope form. You can read the y-intercept from the equation. Well, standard form does not tell us the y-intercept. 2, 3, negative 12, neither of those numbers are the y-intercept, so standard form does not do that. Slope-intercept form, of course, does. It's in the name, slope-intercept. The y-intercept is a negative 4. It's that minus 4 there in it. So, of course, we can see it in slope-intercept form. And then point-slope form. Unfortunately, I cannot see the y-intercept in point-slope form because the 8 and the 6, they make up a point on the graph, but that point's not always the y-intercept. So we do not see the y-intercept from point-slope form. The only time I can see the y-intercept is if it's written in slope-intercept form, which, if you look at the two reasons here, you'll see this is why I prefer the slope-intercept form. Standard form is pretty useless because it's false both times. It doesn't show us the slope, doesn't show us the y-intercept, so I don't really like it. Point slope form is good, but it shows us the slope. However, it doesn't show us the y-intercept. So therefore, it's kind of limited in that sense, and it works and it's functional, but it's not the best. But slope-intercept form is the only one that's true for both of these. It shows us the slope, it shows us the intercept, and therefore is very, very useful a lot of the time. But now let's get into writing more standard form. Let's get used to writing equations in standard form, seeing what standard form is. Now, this is a little bit more of a challenge. In this example, they show you how to do it using point slope. I'm going to show you both ways using point slope or slope-intercept form. Either actually will work out just fine. You could say one's easier than the other. It depends kind of on the situation. I think they're both pretty similar. So here we have a slope of 2 and a point on our line. Now remember, we're trying to write standard form, ax plus by equals c. So none of these numbers go directly into this form. What we're going to have to do is we're going to have to either use point slope form or use slope-intercept form and then change that form into standard form. So we can't actually go directly to standard form. There's no way we can jump straight to the answer here. We actually have to use one of the other forms first and then change that into slope-intercept form. So I'm just going to do this off on the side. I'm going to use point slope form first, and then I'll use slope-intercept form. So I'm just going to show you the two different ways you can write out the equation. So we're going to take the information. This information is a slope of 2 and a point of negative 2, 2. All right. Before we can get the standard form, we have to go through one of these avenues first. Okay, so let's do the point slope first. Now, point slope is probably the best one to use here simply because we have a point and a slope given to us. So point slope form, remember, is y minus y1 equals m parentheses x minus x1. So when I plug this information in, it's simply going to be y minus 2 equal to 2x plus 2. Lots of 2's. So this 2 here is coming from the slope. This 2 here is coming from the y value, positive 2. And then this 2 here is coming from the x value, which is negative 2. Now remember, in point slope form, it's opposite from how it seems. A positive 2 here really indicates that number is negative 2, and the minus 2 here, it really indicates that it's a positive 2. So you do have to keep that in mind. Don't let that trick you. But now we would take this equation, rearrange it a bit until we got it into standard form. So let's see how we do that. How we would do that is we would distribute here the 2x plus 2. So when I distribute, this becomes 2 times x is 2x, and 2 times 2 becomes 4. And then I'll bring down this side. So y minus 2 equals 2x plus 4. Then I would add the 2 to the other side to kind of move it over. And we have y equals 2x plus 6. And now all of a sudden, what I've actually ended up with is slope-intercept form. That's actually slope-intercept form. But we're just one step away from getting standard form. Standard form, remember, wants the x term and the y term on the same side. So what I'm going to actually do is I'm going to move the 2x over to the side with the y. And at that point, it will be in standard form. So to do that, since it's a positive 2x, I will subtract 2x on both sides. And so what I really have is a negative 2x, a positive y on the left, those two terms, a negative 2x and a positive y, equal to 6. And there's your standard form. You have your ax plus by equal to c. You got the x and the y term together, and then the constant regular number off on the other side. So we can also approach this from the slope-intercept perspective. Now, slope-intercept form is y equals mx plus b. So if you were to go this way, here's what you would do. You would use the slope. We know that's 2, so we're going to plug the 2 in for the m. But we're also going to use the x and the y in this equation because I can't figure out what b is right now. Like, I don't have b. I have a slope and a point. I don't have b. b is y-intercept. So the information I'm given in the problem is not the y-intercept. So I actually don't know what the b value is right now. But I can use the x and the y in here. I can use the positive 2 for the y. I can use this negative 2 for the x. And remember, I don't know the y-intercept. I don't actually have that information. So I'm going to leave that as b right now. What I'm going to first do is I'm going to solve for b. So 2 times negative 2 makes negative 4. And then to solve for b, to get the b by itself, I'm going to add the 4 to the other side so that the b can be alone. So this makes 6 equal to b. So now 6 is the y-intercept, which means the equation is, you remember the slope is 2, y-intercept is 6, so it makes the equation y equals 2x plus 6, which is exactly what we had here. Remember, we rearranged it into slope-intercept form. We actually got that equation earlier. And then one more thing, same thing as we did here, is to move it in the standard form, I'd have to move this x term to the side with the y. So since it's positive, I would subtract the 2x. And I'm doing essentially the exact same thing I just did there. So I end up with negative 2x, a positive y equal to 6. Same answer either way, roughly the same amount of work. I'd say the point-slope form is a little less confusing. Slope-intercept form is a bit confusing because what we're really doing is we're plugging in the slope and the point and finding out what b is. And then I'm plugging that 6 value in for that b value, and then I'm rearranging the equation. So it can be a little confusing, slope-intercept, but it still works. And you can see that both those methods are demonstrated here. They've used point-slope form. They've made point-slope form. You can see then they've rearranged it into that final answer of negative 2x plus y equals 6, which is what we got. And then they also do slope-intercept form. So they've used it, they've solved it, they figured out b is 6, and then they wrote the equation with the b value of 6. Then they just rearranged it again, same way to get the same answer. So there's more than one approach here. So let's fill in some of these boxes. So for b, slope is 5 and point of negative 2, 4. So if we're going to use point slope form, which is probably a good idea given the fact that we have a point and a slope, the y value is 4, so this would be y minus 4 equals slope is 5, so this number would be 5, and then x minus this x value, which is negative 2. Now ultimately, this minus negative will look like plus, so that's why you see this plus sign here. So this is actually going to be, well, actually, they're kind of missing a step here. Right here is going to be, let me zoom in. Y minus 4 equal to 5x plus 2. And then what they're going to do is distribute. So 5 times x is going to become 5x, and then 5 times positive 2 now is going to make that 10. So they're actually going to put the 10 there and then keep that 4 there. Okay, so they actually sort of, I wanted to throw that middle step in there. They kind of left out. All right. Now to rewrite this, so they have y minus 4 equal to 5x plus 10. Essentially what they're doing is they're moving the 5x to the other side with the y. So to move that, we would have to subtract the 5x to cancel it out and move it over here. But we'd also have to move the 4. So since it's a minus 4, I'll have to add the 4 to cancel it out and move it over here. The way they've done it is a little differently than I would have done it. I'll show you how I would have done it in a second. Ultimately, though, this ends up being a negative 5x plus a y equal to 14. Here's how I would have wrote it. So we have y minus 4 equals 5x plus 10. I would have moved this 4 first, adding this 4 over here, and having y equal to 5x plus 14, because 10 plus 4 makes 14, and then just move this 5x. Rather than doing them at the same time, I kind of do them separately. So since it's positive 5x, subtract 5x, and you get that same answer. You get the negative 5x, the positive y equal to 14. So of course you can do this a different way. You can use the slope-intercept form. That would work as well. So remember, slope-intercept form is y equals mx plus b. And now in this case, we're using, oops, disappeared. Okay, we're using the slope of 5, and we're using the point -2, 4. So 4 for the y, -2 for the x. So remember, if you use this method, you don't actually have an answer for b yet. You don't actually have the y-intercept. So you're actually doing a problem first. You're actually trying to figure out what the y-intercept is first, and then you're going to use that information later to just rearrange it into standard form. So 5 times -2 ends up being -10, and then bring this 4 down. So when I add the 10 to the other side, I end up with b equal to 14. Remember, this is not the answer. This is just telling me what the y-intercept is. So I know now that the equation is y equals 5x plus 14. Because remember, I already knew the slope was 5. It said in the problem. But after doing this math, I know that the y-intercept is 14 now. So I know I have the equation y equals 5x plus 14. So doing the same rearranging that we just did up here, you get the same answer. So same rearranging means subtract 5x to move the 5x term on the same side as y. And you see, of course, you have a -5x plus y equal to 14. Same answers before. -5x plus y equal to 14. Okay, no, there we go. That's good enough. And that's essentially what this all comes down to. So you have different methods. And if you want to write down which method you prefer and why, you can do that. Everybody's going to have their own preference as to how they want to do it. It doesn't really matter. All right, so let's try 4 and 5, and you can use whatever method that you want. I'm going to do both methods for both problems. So if you want to pause the screen and try it yourself, you can, and I'll show you both methods either way. But I am going to do them all to the side. So if you want to get started, we'll get started. Like I said, pause the screen if you want to do it. Otherwise, I'm just going to go ahead and work them out. So slope is -2 and then -7, -10. So -2 and -7, -10. All right, so if I do point slope form would be y plus 10 equal to -2x plus 7. Hopefully you can do that by now. Hopefully I don't have to explain how I got that. Just remember these two negative numbers are going to show up as a positive numbers here, +7 and +10, and the slope's -2. That's pretty self-explanatory. So when I work this out, I'm going to distribute. This will be -2 times x and -2 times 7, which makes -14. I'm going to bring this down. So now I'm just going to move the 10 over. So I'm going to subtract 10 on both sides and have y equal to -2x minus 24. -14 minus 10 makes -24. And now the last thing to do to get this in standard form would be, since it's a -2x, would be to add 2x to the other side to combine it with y. So ultimately we have a positive 2x plus a positive y equal to -24 as the answer. Now, if you do the same problem, but using slope-intercept form, you would have this. So slope-intercept form is y equals mx plus b. So we would plug in -10 for the y, we'd plug in -2 for the slope, and we'd plug in -7 for the x. Now remember, if you use this method, you got to be careful because you don't actually know the b value. So we're going to figure that out first. So this ends up being -10 equal to -2 times -7. Now -2 times -7 is a positive 14. And again, just bringing that b down. Then subtract the 14 to get the b by itself, positive 14, which is why I'm subtracting it. And this ends up being -24 is equal to b. So this tells me that since I know the slope is -2 and that the b value is -24, that slope-intercept form would be y equals -2x, because remember, slope's -2, and then minus 24, because the y-intercept is minus 24. And then you repeat the exact same process that we did here, which is add the 2x to the other side, and we have the final answer as 2x plus y equals -24. Both methods take about equally as long. Both methods are equally as good. Either is fine. Now, if you want to try number 5, you can pause the screen, try to do number 5. I'm going to do the same thing where I just work it out over here on the right-hand side. So do what you got to do. And if you're ready, I'm going to get going. So 4 and -3, 0. Let me do it down here. So slope is 4, and the point is -3, 0. Just double check. Yeah. So point slope form would look like this. We have y minus 0 equals 4, and then x plus 3. Now you might notice that this -0 is pretty useless to have since it's -0. So let me distribute and get rid of that -0. So when I distribute, 4 times x is going to be 4x, and 4 times 3 becomes 12. And on the other side, I'll just ignore this -0 since it's pretty useless. So y is equal to 4x plus 12. Now that's slope-intercept form. Now to move it in standard form, I just have to move the x over to the y side. So since it's a positive 4x, we'll subtract 4x just to have it move over. And we end up with a -4x plus y equal to that 12 as our answer. So point slope form is probably going to be the best one to use, but let's also look at slope-intercept form. So slope-intercept form would be like this. We would use the 0 for the y. So 0 for the y. We'd use that 4 for the m, and we use the -3 for the x. And we're looking to solve for b. So this ends up being 0 equals -12 plus b. 4 times -3 makes -12. And then simply add 12 to the other side to kind of cancel it out and get that b by itself. So 12 is equal to b. So now that I know the slope is 4 and the y-intercept is 12, that equation would be y equals 4x plus 12. And then, of course, same process we did here, which is just move the 4x over to the y side by subtracting 4x. So subtract 4x, cancel that out, and move it over to the y side. Ends up being -4x plus y equal to 12. Same answer, again, as the last way. Remember, each technique is going to have their own pros and cons. In this particular case, point slope form was definitely the easier one. But, it's very repetitive. It's the same thing every time. So if you want to use slope-intercept form, if you want to use point slope form, it really doesn't matter. Just become a master of whichever one you like more, and that's all I can ask for. You don't have to be able to do it both ways. I'm just showing you both ways so that you can choose. You have the freedom to decide for yourself which way you want to do it. Now we're going to write a standard form equation, but we're going to be given 2 points to do this. So what we're going to do is same idea, right? We still need to know the slope. I've got 2 points, but I need to know the slope. Now for this one, just to make things a little easier, we're going to stay strict on point slope form. Just going to stick with point slope form, just to make this a little faster. Because doing it twice is going to take a long time. Once for point slope, once for slope-intercept. So we'll just do point slope, just so we can only have to do it once. So we have 2 points, and just like in section 6.2, we're going to find the slope from these 2 points, which is the y values minus the y values, and the x value minus the x value. So x, y, x, y. So the y values minus the y values. So that's going to be a -6 minus a 2. -6 minus 2. And then the x value minus the x value would be 3 minus 5. Now this ends up being -8 over -2. So be careful with that subtraction. That can be kind of tricky. But we end up -6 minus 2 is -8. 3 minus 5 is negative 2. And the two negatives actually end up canceling, making 8 divided by 2 actually just a positive 4. So the slope is 4. That's very useful because now it's pretty much the same as one of these problems, right? We know the slope. We also know a point. Just like here, we knew a slope and a point for both of these. Now, you only need 1 point, but you've got 2 to choose from. So let's say you choose the point 5,2. You only have to pick one of them. So let's pick that one. If we do that, our y value is 2. So this will be y minus 2. Our slope is 4, and then our x value is 5. So there's our point slope equation. So when we rearrange this, or if we work this out, this would be y minus 2 equal to, distribute here, 4 times x would be 4x, and 4 times negative 5 would be negative 20. If you use the other point, I'm just going to throw this in here just for completion. If we use the other point, the y value is negative 6. The slope is still 4, and the x value is 3. So that means this would end up to look like y plus 6. And when I distribute, this would be 4 times x would be 4x, and 4 times negative 3, which would be negative 12, or minus 12. Now, either way, both of these equations, which I'm going to write down right now, y minus 2 equals 4x minus 20, which is this one. And the other equation, which is y plus 6 equals 4x minus 12, they should both rearrange into the same standard form equation. So if I do that, let me add 2 on this one to cancel that 2 out. We'll have y equal to 4x minus 18. And so when I rearrange this, I'll subtract the 4x to move it over to the y side. And we have negative 4x plus y equals negative 18. And if I do the same thing on the second version of this equation, the one down here, this one, I should end up with the same result. So I will subtract 6 because that's the opposite of plus 6 to cancel that out. We end up with y equal to 4x minus 18. Again, the exact same equation. So everything else is going to be the same thing that we did here. Subtract 4x to cancel that out and move it over here with the y side. And we end up with the negative 4x plus y equal to negative 18. Same result. Negative 4x plus y equals negative 18. So also keep in mind, you could still do this even with slope-intercept form. Like I only did this whole problem using point-slope form, but I could do all of this again using slope-intercept form. But obviously, I'm not going to do that just because it's going to just, it's just going to take up a lot more time than we need. But you can do it. You can do it. So I'm going to finish here with number 7 and number 8. So let me zoom in on these. So remember, the first thing we need to do is find the slope, which means y value minus y value. So the y's go on top. Y minus y on top, x minus x on bottom. So the y's are negative 3 and negative 7. So we'll have negative 3 minus negative 7. And the x's will be 2 minus 4. Now, when I simplify this, negative 3 minus negative 7, or essentially negative 3 plus 7, ends up to be 4. And 2 minus 4 ends up to be negative 2. And this, 4 divided by negative 2, is actually negative 2. So our slope is negative 2. Now, if I use point-slope form, let's just use one of the points. I'll use this one just because the numbers seem a little smaller. So if I use this one, this point, and this slope, then my equation would look like this. I would have y plus 3 for that negative 3 there, equal to negative 2 as our slope, x minus 2, and the minus 2 is because of this 2 right here. Right? So that's point slope form, but remember, we're trying to write standard form. So what I'm going to do is I'm going to distribute here first. This will be negative 2 times x would be negative 2x. And negative 2 times negative 2 would be positive 4. So bring down the y plus 3. We have it equal to negative 2x plus 4. Now, let's subtract 3 and combine it over here on the other side. So this would be y equal to negative 2x And then 4 minus 3 would be 1, positive 1, so plus 1. So let me move this over here real quick. This is y equals negative 2x plus 1. Now, this is slope-intercept form. But all I need to do to move it in standard form is just move the x term to the other side. So to do that, I'll add 2x to cancel it out, move it to the other side. So that means we'll have 2x plus y equal to 1. So the answer there would be 2x plus y equals 1 as our standard form equation. Now you'll still get that same answer if you plugged in the other point instead. There's only one correct answer, and that's it. But there is definitely more than one way of getting there. Now if you want to pause the screen, try number 8, go for it. I think you can handle it, but if you want to watch me work it out, let's do that too. So remember, find the slope, x minus x, and y minus y. Y is on top. Y minus y, x minus x. So the y's are negative 6 minus 5, and the x's are negative 10 minus 1. Now when I evaluate, this becomes negative 11 over negative 11. Now, negative 11 divided by negative 11, notice the fact that they're both negative means that this becomes a positive 1. Because 11 divided by 11, of course, is 1. The two negatives cancel and make it positive 1. So our slope is positive 1. Now, we can use either of these points. I'm going to use this one just because it seems easier. So if I use point-slope form, the point-slope form would be this. Y minus 5 equals 1. That's the slope here. X minus 1, which is the 5 is from the y value here, and then this 1 is from the x value here. And then that 1 is from our slope. So if I'm going to rearrange this in the standard form, the first thing I'm going to do is distribute. So 1 times x is 1x, and 1 times negative 1 is still negative 1. So this is y minus 5 equals 1x minus 1. Let's add this 5 to combine it to the other constant. So this ends up being y equal to 1x. Now negative 1 plus 5 is 4, so positive 4. Move this over here real quick so I have more room. Y equals 1x plus 4. Now 1x is the same as just regular x, so I'm just going to change it to x, but it is the same thing. Now remember, this is slope-intercept form, but all I got to do to put in standard form is to move the x term over. So let's do that. To move it, since it's a positive x, we'll have to subtract x to move it. So that means at the end of this problem, we have negative x plus positive y equals 4 as our final answer. So remember, it's negative x plus y equals 4 is your standard form equation. All right. Now, I'm going to end that video right there. Yes, there are word problems to this, but fundamentally, they still follow the same math that we've done here. So you just need to know the slope and the points, and you're good. But yeah, I'll end that video there. So if you have questions, let me know. That's it for section 6.3. See you in the next one.